someone who brings data into life, quite literally. Please welcome Revathi Prakash. Not to rush for break. Please welcome Revathi Prakash, as she loves us to call her Rev, data scientist at Doordash. We all have heard about Doordash. She has spent nearly a decade transforming retail data into powerful business insights. She has previously worked with the Iconic and the Global Fashion Group, developing analytical solution and building smart algorithms that enable leaders to make data-driven decisions. Today, she will be walking us through how data science is shaping real-world decisions and how we can make analytics not just informative but truly impactful. Please join me giving a warm welcome to Revathi Prakash.
Hi everyone, good morning. Thank you so much, Sheetal, for the warm intro. I hope it works. Yes, it works. So I think Sheetal had got a brief intro about me, so let me introduce myself again. So I'm Ray, I'm leading the consumer analytics for Doordash, Australia and New Zealand. So hopefully I'm loud enough. I'm normally very loud, that's what I get the feedback.
We're recording this one.
Oh, sorry.
If you want to use it, you can switch between.
Yeah. Maybe I'll speak here because it's mostly a hands-on session, so I just want to be close to the laptop. Is this fine? Yeah. Yeah, cool, thanks. Yeah, all good. I think you all can hear me pretty well and loud. So I've been in the data industry for almost 12 to 13 years, having worked across almost in all retail kind of experience. So because Barkha talked about a bit about her background and how she transitioned into the role that she is in at the moment, I just want to touch base on it. I haven't put a slide here, but pretty much I started as a software engineer back in the days with Amex, then moved to PayPal, and then started with Iconic. That's where I transitioned into a data science role, and I've worked there quite a number of years, moving from data science to leading a data science team, and from there moving to Doordash, so where I'm currently. So Doordash, as you all know, is kind of like a food delivery company, so a lot of my experience has been a lot on the e-com side of things. And today, coming into this presentation, I wanted to touch base on an area which is considered or underpinned, but it's kind of like the bread and butter for the FANG companies, if you think about it. So today we are going to be actually talking about how do you actually supercharge your experiments using GCP. Before we start, I just want to ask a question. How many of you have done any kind of experimentation? Experimentation, I mean an A/B test or diff in def or something around that. Cool. I see actually a few hands up, which is pretty good, because one of the things I've always found while interviewing or talking to people is the way or the extent to which experimentations are done in the companies. A lot of them are not at that scale to do it, or some of them actually do it, but to make the most of it, they haven't actually been at that maturity. Luckily, I've been lucky enough to be part of a company where experimentation is like a bread and butter, and it's being considered to that stage, even a very single decision on the website goes as an experiment, and you need to prove it with data that it's worth putting that feature in front of the consumers. So I just wanted to actually bring what the experimentation does and how it is actually beneficial for for your website or for your business, and with all these AI things going on, how GCP can actually improve on it and help implement it in the most efficient way. So just running through the agenda, so I want to touch base on a few of the experimentation basics. I'll be doing a demo, so I'll have a data set. I want to actually run you through how do you infer how that experiment results actually look like. Now, most of the companies actually stop at that point in time. I want to probably dig a bit more into it in terms of concepts like uplift modeling. I'll touch base on it, what it is and how it is actually used across the companies and how do they make the most ROI out of it. So I just want to touch base on it and how GCP can actually like enable these components in the most efficient way. To start with, I know there has been a few hands when I asked about like, have you done any kind of like experimentation, which is like a really good kind of like audience, because I was thinking like when I had a chat like earlier, a lot of people didn't have like experimentation like background or haven't done, because if you think about data science at the moment, there is actually like two umbrellas I would consider of it. One is the predictive side of things, which is what most of the people are working on. Given a set of conditions, whether this consumer will convert or not, whether you are going to get a next purchase or not. But there is this other side of data science, which is like very interesting and a lot of like econ based, which is causal inference kind of things. So causal inference is all about what happens if I intervene at this point in time to this consumer, or it's more around counterfactual events and hypothesis, and then you try to actually like figure out like, is it even beneficial to my kind of the business outcome that I'm actually trying to do. So between these two umbrellas, I'm going to be focusing on the second part, which is more on the causal side of things, which is where you'd actually do a lot of experiments and things like that. Now, why experimentation? It's a scientific way of like proving out whether the product decision that you are going to make is the right one or not. Now, there are different ways in which you can actually like do experimentation and stuff like that. The most common way is, which you might have heard of, is an A/B test. What is an A/B test? Let's say you have a website and you wanted to actually like introduce a new button. I'm just going for the very simple kind of like scenario. How do you actually like even know if that is the right move for your consumers, if they would love that experience? Normally what happens is kind of like, because they don't have that scale to experiment, companies usually just put that new button in and then potentially track how consumers have interacted with it, and then see if there is a like key uplift in terms of like conversion. So conversion is like a e-com metric, which is like if you land on the website and you basically become a purchaser, you consider that as a conversion. So most of the companies do kind of like a pre-post, whereas when you are like literally living in like a data-centric world where every decision is backed by data, what you want to understand is like, if I put that new button outside to 50% of consumers or like 20% of consumers, I want to see what is the difference in whatever the key metrics that we want to track. Let's say I am putting out, my product manager is coming to me and saying that I think a green button is going to make more sense for a particular page. So what you tend to do with an experiment is, if I put out that green button out in front of the people, is it going to give me like 1% improvement in my conversion rate? That's what it's going to give you. So now with the experiment, what it actually like unwraps is, it basically gives away the myth that is behind it. Because earlier when I was telling you, when companies just actually roll out that feature, they go with the assumption that, okay, this is supposed to actually like work well. They don't have any data to back it up. It's basically the assumption that goes with it. So experimentation takes away a lot of your guessworks. And it also helps you with a lot of debiasing, because I know human beings have a lot of bias. Each of us have got a different set of bias for different reasons, because of our like beliefs, because of our upbringing, and a lot of aspects. But experimentation doesn't care about actually these biases. It basically makes that decision based on the data and helps us guide us through what is the right thing to do for the business. So that's why experimentation is like very important and very valuable when you scale your companies and like when you get your company to a matured size. I might actually like assume here kind of thing when you are potentially like in your startup phase or growing phase, they wouldn't make much sense because you are trying to move through, you're trying to prove your product. So experimentation might or might not add a value depending upon like what your business model is and things like that. But when you actually like mature, you want every decision to be data based so that you can get the best out of it. I might just put a pause here. I'm happy to actually take questions as well as we go, but I have to run through a demo as well. So yeah, let's see how it goes. I hope I'm seeing like few notes, so I feel like people are following through, but let me know if there is any concept that you want me to actually explain a bit more. cool. So I'm going to run through an example, and this is where we are going to be actually doing the inference experimentation on. So I think I touched on it a bit in kind of like lighter shades. So we want to introduce a new feature on our homepage. Let's say we have an e-commerce website which allows us to purchase clothes or whatever we are actually like doing. Now, we want to introduce a new feature on the homepage or any of the pages, and the product manager comes to me and say that, hey, we think this product feature is going to actually improve our conversion rate. Do you want to see like how it works and like let's test it out and see like whether it really benefits, or is there any trade-off with that particular decision that we are going to make? Now, I'm going to assume here we are doing a lot of groundwork already, because I didn't want to go into the lot of details of like how you experiment and how you set up experiment and things like that. Like if you have done experimentation in the past, like when you launch an experiment, what you start with is, let's say, I want to actually do this feature. Do I do 50-50, or how long should I run for it to get actually a good result? Is that result going to be always replicable if I deploy it into production? So these are some of the questions everyone will have. And what you tend to do is kind of, there are stats tools that are available at the moment which helps you decide what is the sample size required. What I mean by sample size is, like if I put out this feature on a homepage, it might just tell me I need 50,000 users on each of these variation, and it needs to run for like 4 weeks to get a 1% uplift. So you start with these base parameters, and then you decide like how your experiment design is going to be, which is pretty much understanding what is the sample size you require, what is the MDE, which is the minimum detectable effect, like I said, 1% uplift that you want, and how many weeks do you need to run this experiment. So I'm going with the assumption here that we have all worked that out. We identified it's a 50-50 split. We are going to run it for 4 weeks. And I'm here at this stage where I have the data available in BQ. Now, how do you actually like figure out, has the experiment actually worked or not? So that's where we are at the moment. I'm just going to go into a demo mode. I hope the demo mode works today. Let's see. Yep, so I already have like set up this data. It's a synthetic data set that I've created in BigQuery. I just want to show you a preview of like what the data looks like. So I'm at this stage, and I'm a data scientist, let's assume, working on this project, where I've got this data available, which is basically at a user ID level, where you can see there is a segment which is going to tell me whether that user is a new user or a returning user. And the variant is actually what it tells me whether I'm seeing the new version or the old version. And you can see I've worked out and put it out as a binary here, whether the consumer has converted or not, because conversion is what I'm actually considering as my primary metric for this experiment. Now here comes the beauty of all this flashy Gemini and kind of tools that's available in BQ. Even if you are actually not a data science, if you have got the basics of understanding of experimentation, you can actually make use of that and let the Gemini or kind of the utility that is available in GCP to give you that inference. Was the experiment a success or not? That's what we are going to potentially see. So I've created actually a notebook, which is a very simple notebook, nothing fancy. Yeah, so you can see here I've just provided the very basic information of okay, this is my table. You can see I'm just looking for whether the data loads and very, very, very basic stuff. So this is where it gets interesting. So one of the bigger things I've always, because there is a lot of AI usage even in my day-to-day life, and one of the biggest learnings that I had with that is your AI is going to be as good as your prompt is. So that's why you can see there is a lot of focus on prompt engineering. How do you actually get your prompt right? So a lot of what AI actually gives response and whether how much hallucination it has really depends upon the quality of the prompt that you actually give it to it. So you can see here, I'm just giving a like very basic prompt. I have the prompt written because I just didn't want to actually like write it while I'm doing the session because of the time constraints, but I'm just going to walk you through it. So you can just see it's just plain English. I'm just telling using the table, which I showed you about, with the columns, these, run an end-to-end A/B test analysis, show conversion rates for the variance, test for statistical significance. So I'm not going to go into the too technical details of statistical significance. So statistic, I know I've got 10 minutes left. So, but in general, what statistic is going to give you is, let's say if I run this experiment and I found that it's going to give me like 20% uplift. Am I able to replicate that 20% uplift 95% of the times? Kind of giving me the confidence that, okay, if I deploy this, it's going to be actually like giving me that 20% uplift like 95% of times for all users. So that's the confidence you basically have, which gives you enough evidence to deploy that particular feature that you want to. Now you can see I'm testing for statistical significance and then explain the results in plain English with a recommendation for product manager. So you can see very simple, very Englishy kind of like prompt that I have given. Once you give this prompt, this is the code that it actually gives you. Very straightforward code. It gets the data, gets the conversion rate by each kind of like variant. You can see it's going to actually like tell me what is the statistic level. If you know the basics of stats, anything less than 0.05 for the p-value is what you consider a statistic, and you don't need to know about it. That's why I basically made the prompt to say that give the recommendation to a product manager. So the code itself actually takes care of that, and you can see, so it's a synthetic data. So my first variant has a conversion rate of like 49%, and you can see here the p-value is like 0.00, which is like statistically significant. So the end result is like, this indicate that there is a statistically significant difference between conversion rate and the recommendation for product manager is the variant 1 is actually like high performing than variant 0. So it's a good decision to actually like deploy that particular variant. So I didn't do actually much of any kind of like hard uplifting. I just gave it a prompt and it basically like did the whole coding for me. Now with a lot of these experiments, we use a lot of AI in our day-to-day life as well. I think you still need actually that econ kind of or the base knowledge to understand what's going on. But the beauty of all the Gemini and GCP is kind of, it takes away like a lot of your repetitive task efforts. Like, you know, this code is, you can actually just write it by yourself as well, but there is not point in actually putting in time to write this code, except that the key takeaway or the key benefit is you understanding, okay, what you have actually put in terms of the data, whether that data actually makes sense and the result makes sense. So a lot of actually like uplift in terms of like the code writing and what is being actually taken away, or that's the time that's getting freed up for us. Cool, I might just pause a minute just for everyone to have a breather, just getting to know everyone is following me until here. Cool, awesome. And I just wanted to actually touch base on one more thing, and I think we have got like 5-6 minutes left. So yeah, cool, awesome. So primarily wanted to show how Gemini prompts can actually help you get a gist of what the experiment inference is. Now, most of the companies actually stop here in terms of, okay, I found that variant 1 was actually performing well, let's just deploy that. But what most of the FANG companies does is, you go one more level deeper into the results. Okay, I understand variant 1 was actually working. That's not what I want to know. For whom variant 1 was working? Because my ultimate aim is, how do I maximize ROI from a business point of view? That's what everyone is actually aiming for, right? If you invest $1, how do you get $10 or like $1,000 out of it? If you have a scenario where you can get $1,000 out of it, you definitely want to go for that rather than having to go the pathway of like $10. So when you run experiments, you get average results, which you might end up having like $10 advantage. But when you go a bit more deep dive and understand the exact segments which works for that particular feature, you might just actually get an uplift of like $30 for the investment you are actually making. So that's the concept of uplift modeling. I just want to briefly touch base on it because I know we are running out of time, but Yeah. So uplift modeling is another field of this causal inference methods where, I don't know, you might have heard of meta learners. So there is a lot of kind of like good stats and econ, no, like documentaries and like documentations and very good libraries, which basically does a lot of these uplift modeling. But under the hood, they are like conceptually very simple. It all goes back to your old regression, XGBoost regressors. They are all the backbones of these kind of like meta learners. What it primarily tries to identify is, let's say, without giving that treatment, 50% of the people would have converted anyway. But because you bucketed them in treatment because of your RCD, you are going to muddle around the uplift that you got. So what you end up doing is kind of like using basic ML techniques. You try to identify whether you are going to get an uplift giving the treatment or not, and then you identify the segments which basically benefited from it. And what you end up doing in such kind of experiments is, if you see there is a targeted segment which is going to be mostly benefited from it, you just actually deploy for that particular segment. So, and it's an iterative process. All experiments are iterative process because there is no golden rule which basically says that, okay, this is the end of it. You always keeps on iterating on it to make your product perfect in different directions. And last piece of thing that I want to touch on uplift modeling as well is, I've created actually a notebook. I can share these notebooks and codes with you later. Like, again, kind of like similar, I've created another notebook in Vertex AI because Vertex AI and BigQuery notebooks are backed out of Collab runtime, so you can just create it. Now you can see here what I have done. So I'm not going to actually like type it again possibly because of the time constraints. So I'm an expert data scientist and I want to actually do an uplift modeling based on this data set, and I basically provided, okay, these are kind of like what the data set features are, and these are actually like what I need. So the Gemini model basically responds back with the code I need, which is pretty much what the uplift modeling does. Is, as you can see, these are the features that I have additionally provided for the experiment data. It's going to actually tell me, based on this code, age 20 to 30, who has been with us for 40 days, and average water value of 20 are the best people to actually like having the uplift for. So very generic code you can see, and I wanted to show you the result of it as well. So this is pretty much what it basically gives us. What you're seeing in the graph is the uplift that is actually provided based on cutting the consumers into different bins. And how you make a decision is, you basically wanted to deploy the particular feature for the group of consumers which has the highest point here. So potentially, like, look, we are looking at it like the 50 decile consumer is actually the one where you're going to get most of the benefit. I might just actually like pause here. I know there is actually a lot of information that I was trying to actually munch through in 30 minutes, and maybe some of these concepts are actually new to you, but I just wanted to actually like touch base on this topic because this is one of the most undermined areas at the moment, which is why there is a lot of opportunity if you want to actually like double down in this area. Like, I don't know, like there are a lot of public companies who have done these products. There is Statsig, if you have searched for it. Only very few companies have actually done this product right and have got it right. So there is a lot of opportunity. The downside of it is like getting it right is really hard because you work through like a different set of conditions and combinations. So you have to think about like 1,000 different kind of like scenarios to get it right. But a very, very, very undermined area, but a really beneficial and useful area. So that's why I wanted to open up this, like at least the basics of it, and want people to think about in this area. If you are actually starting in, or if you are in data science field and looking for like opportunities, this might be a good area to tap into. And I think that was it for my presentation. Happy to actually take any questions here or like offline. Thank you so much.
Yeah, thank you so much. Hello. Thank you, Rev, for such a practical session. We will open floor for at least 2 questions. Yeah. Yeah.
Hello. Hi.
I think it's not working. Oh, it is not working? It is.
Hello.
Yeah.
So I just want to confirm my understanding, right? So when we do experimentation, you just mention an example. From the whole population, we go for 50%, and that 50% include all the segments of customer, and then you go and realize that there might be different uplift for different segments of customer. When you go to production, you only apply a certain feature only for that customer with the highest uplift. So why is that? We can do for everyone. Of course, segments gets more value other than, but why? And doesn't this make a lot of complexity if you want to just apply a feature for a certain customer and then for a second feature again, this doesn't make the whole thing is very complex?
Yeah, a very good question. It really depends upon what feature you are trying to deploy. So if for website features, I would say it's like a lot of overhead. Potentially, you just actually draw it out right for every consumer. But if you think about, if you're actually like doing it for an email kind of like personalization or something of that sort, you have the flexibility to be more personalized in that aspect, and that's where it might actually add more value, to be honest. Like deploying a feature, I would say, like sometimes you end up, it also depends upon the maturity as well and the way you want actually these consumers experience to have. If it is a very simple thing, I don't think that a lot of companies find value in the overhead that it has to actually maintain different versions for different set of consumers. But for some specific like workflows and stuff like that, companies do find it useful. Yeah.
Thank you. And then something else, how do you do risk assessment like in Doordash? Like, do you actually go for the whole population, or do you have like tiers of customer, and you might be worried that if segments there's high risk, so you just be more cautious and do it later? Do you do this kind of thing?
Yeah, that's also a very good question. It really again depends upon like what feature, and because Doordash is like a three-sided marketplace, you have got consumers, you have got dashers, you have got merchants. It really depends upon the extent and impact of that particular like feature that we are trying to do. For most of the consumer side of things, we are quite like again case by case, but we might be comfortable doing a lot of A/B tests. But a lot of the other pillars, we don't have the flexibility to do that because it might be detrimental sometimes. So we end up doing sometimes the other side of experimentation, which is like definitive, causal estimates and things like that. So like counterfactual estimates and things like that. So it really kind of like very, very scenario based, and you will have to assess risk for all the experiments, and it needs to go through an approval process if your risk score is actually higher than the particular threshold. So yeah, there is an evaluation definitely happening.
Yeah, also, and I think the last question, like, which is like the most challenging one, is like, how do you account for other factors and keep them
Sorry.
for other factors at the same time in your experiment? How do you make sure that other things are not going on at the same time, or how to separate other factors?
Yeah, so it also depends upon what type of experimentation framework that you are using. For A/B test, it's perfectly normal because you are just randomizing and every other factor you are assuming to be stable across the board. Yeah, same happening across the board. The issue normally happens when you do a lot of definitive kind of things. Then you make buffers and assumptions around actually like the external factors. You potentially consider 3 or 4 external factors and then factor in, okay, this is what is the buffer that normally happens for these, and this is how you control for it. So you will control for actually the other covariates that can actually influence that decision.
I think it really depends on the context of the problem.
Yeah, exactly.
Because I was working on a store solution, and across different store, a lot of other experiment was happening, so we had to make sure we
exactly.
all of that, and the population we choose, making sure apple to apple.
Yeah.
Yeah, awesome. Thank you.
Thank you.
We have one more question at the back. We will try to make the question really short. Yeah.
So my understanding that A/B testing and uplifting modeling, those are two different approaches. A/B testing is more straightforward. It's like system in status A compared to system in status B, and then you just choose the preferable, which one is preferable. Does it mean that uplifting modeling is more like predictive modeling rather than that type of modeling that is based on data, backup by data, like in A/B testing? So in such a case, if it is a yes, it's more like predictive modeling, then how do you validate the model? You train the model, based on some assumption? And then how do you validate this model that would ground you that your assumption was correct? Because there can be like 0 or 1, there can be assumption was right or it was wrong, and then you have to roll back all the changes. So what's the drill with that?
Yep, that's also a good question. So RCTs and uplift modeling comes with a lot of assumptions, and like in static, like if you need to have like perfect balance, you need to have like the mean standard error should be actually within the guardrails. So even if you are doing like uplift modeling on an RCT example, like if you do an A/B test, you can actually use uplift modeling on this data. The training data will be based on whatever the experiment data. It has to actually go through a set of rules, and if those rules are actually passed only, you would assume the result that you are getting it is valid for even consideration. So it again matters like if it passes the check marks, and if again you see the uplift as really good, that's where you deploy it. But if it doesn't pass as a check, which is basically might be just random kind of like observation that you might get, you won't actually go and deploy. So there is a lot of kind of like considerations and lot of evaluation steps that we do in the middle of it, just making sure that whatever we are doing, even though it's actually like a predictive model for uplift, it's based on an RCT data, it's again valid at different levels. So the conclusion that we are drawing is the right one.
Is there any way that inconsistency data, when you have got the repeat, the running again, and give you the threshold, or the data is completely different, or give you something like the 0 is better than the 1? Is there any kind like that? I mean, does the accuracy and the inconsistency of data when you say that you predictive model, is that you can retrain model by yourself? Or?
No, so that's not, so when you do a lot of uplift modeling, it's not about actually making the model accurate. I don't want the model to be more accurate. I just want to stay at close to like random as possible, because that's when you basically know it's a randomized assignment. Like if I'm able to predict whether that consumer is going to convert based on other factors, that basically means that there are other confounding factors influencing that conversion rather than my experiment. So uplift modeling is more around understanding if that treatment was given or not given, is that consumer going to have a uplift or not. So it's not about making the model more kind of like accurate, it's more about like counterfactual, identifying whether that uplift was or whether that intervention was meaningful or not.
Have you ever thinking about RAG pipeline to more accuracy on your data, so that means that the next time when you have something, you have some complex, you have some encounter, you have other factors, so that you can use that RAG another layer to more have your accuracy, and it means that to improve the consistency of the data.
Is the are you hinting towards like some frameworks that we normally use, or like some methodologies? Oh, okay, the RAG pipeline kind of thing. Yeah, so there is actually like a whole set of pipelines that we do normally for a lot of these validation checks, and they are actually in place, basically ensuring whether the data is actually like good quality or not. Can it actually go through the experiment? Because not all experiments are actually like successful. There are a lot of experiments which has actually failed as because of data quality and things like that. So there is RAG pipelines or like different set of pipelines that we have got in, which basically ensures the data is actually quality or not.
Well, that's very awesome questions. We have such a lovely audience who really want to have a lot of questions. Rev is here. Please join her during the lunch break and have a chat about more of the data and yeah.